My name is Bob Sandford, and I hold the Epcor Chair in Water and Climate Security at the United Nations University Institute for Water, Environment and Health. And in this capacity, I work to translate the latest scientific research outcomes into language the average person can understand and that decision makers in government can use to craft timely and durable public policy. I also work to bring international example to bear on Canadian water and water-related climate issues with the express goal of dispelling the myth of limitless abundance of water in this country. The idea that Canada possesses 20% of all the fresh water on Earth has been a source of Canadian pride since before Confederation. Unfortunately, it's just a myth. While we possess a great deal of water in some parts of the country, much of that water is left over from the melting of the 2-kilometer deep ice sheets that covered almost all of Canada at the close of the last Great Ice Age. Most of our water resources are concentrated in the Great Lakes region, or far from where many people live in deep, cold lakes in the Canadian north. Only 6.5% of the water we claim to possess is returned to us each year through the annual precipitation cycle. And it's also important to note that there are large parts of Canada, including the prairies and the deserts of south-central British Columbia, that are genuinely water scarce. Another nagging truth eating away at the myth of limitless abundance of water in Canada is the fact that we are among the most egregious water wasters in the world. We also pollute a great deal of our water, effectively removing it from the water cycle, often at great expense to natural ecosystem function. It should be surprising to no one, then, given that we take our water for granted, that some of the symptoms of overuse and contamination that are the foundation of a growing global water crisis elsewhere in the world are beginning to appear here. Among the biggest threats to water supply and quality in Canada are posed by industrial agriculture. What we appear to need is another green revolution, but this time focused also on addressing the unintended consequences of the last green revolution. This next revolution should focus on soil health as a means of mitigating and adapting to extreme weather events such as floods and droughts, and on the ability of healthy soils to pull carbon dioxide from the atmosphere and to capture and store it in the vast agricultural landscapes we're going to need to create a sustainable future. Far outweighing these threats to the myth of limitless abundance of water in Canada is the fact that by way of our needs and our numbers, humanity has begun to accelerate the rate and manner in which water moves through the global hydrologic cycle. What is fundamentally being effective is what people working in water call stationarity. Stationarity is the notion that seasonal weather and long-term climate conditions will fluctuate predictably within established limits, limits familiar to us from our experiences of the past. Unfortunately, that certainty no longer exists. The statistics from the past related to how surface, subsurface, and atmospheric water will act under a variety of given circumstances are no longer reliable. And this, we have recently discovered, is a lot more serious than we thought. It's now widely held that continuing to assume hydrologic stability in designing our cities and our infrastructure and planning to supply water to growing populations or water to grow food is no longer practical or even defensible. The myth of limitless abundance of water is not going to survive this assault. So, one might ask, what's going on out there? The most profound changes to the hydrologic cycle relate to how much more water a warmer atmosphere can hold. We have known for more than a century that for every degree Celsius of warming, we can expect the atmosphere to carry 7% more water vapor. So if you increase the temperature of the atmosphere by 2 degrees, the atmosphere can carry as much as 14% more water. And if you raise the temperature of the atmosphere by 4 degrees, it will carry 28% more water. And that changes everything. This, in combination with rising sea surface temperatures, allows for extreme cloud bursts and storms with greater power that last longer and carry more punch. We're also witnessing things that we either haven't seen or weren't able to recognize before, and these include atmospheric rivers. Atmospheric rivers are corridors of intense winds and moist air that can be 400 to 500 kilometers across and thousands of kilometers long. They can carry the equivalent of 10 times the average discharge of the St. Lawrence River. And these huge rivers of water vapor aloft are carrying more water and causing flooding of magnitudes we've not witnessed before. What we're also discovering is that the ratio of snow to liquid water in the great seasonal redistribution of precipitation in the Northern Hemisphere is changing with huge potential consequences for all of us. And nowhere is that more evident than west of us in the Rocky Mountains. Researchers demonstrate that have lost 300 glaciers in the Mountain National Park regions of the Rockies alone in the 85 years between 1920 and 2005. And this loss is expected to continue with over 90% of the ice that exists in the interior ranges of Canada's western mountains expected to be gone by the end of this century. This loss of glacial ice, however, is a symptom of a much larger problem. The same warming that is causing our glaciers to disappear so quickly is reducing snowpack and the duration and extent of snow cover throughout the Mountain West. Snowpack and snow cover are now declining by 17% per decade, and by mid-century, hydrologists feel the Canadian West will be as changed by this as it was by European settlement. What we're also seeing is that the loss of Arctic sea ice and the rapid reduction of the extent and duration of snow cover in the Northern Hemisphere are impacting the behavior of the jet stream. What is new is the growing realization of the extent to which Arctic sea ice acts as a thermostat controlling climate right down to the mid-latitudes throughout the Northern Hemisphere. And it's important to note that yesterday, the temperatures over the North Pole and the Arctic Ocean were 20 degrees Celsius above normal for this time of year. There is less ice there is in the Arctic, the slower and wavier the jet stream becomes and the more erratically it behaves. And recent research has demonstrated that the Alberta floods of 2013, the Assiniboine flood of 2014, extreme drought on the prairies in 2015, and the Fort McMurray wildfires in 2016 all appear to be linked to human-caused climate change effects over the Western Arctic. The Arctic is now well on its way to becoming a driver of, rather than a responder to global change. In closing, there is a direct link between water, land, and climate. It's well known that 90% of global heat dynamics are controlled by hydrologic processes. To restore the water cycle, we need to manage land and water as living systems. And to do that, we urgently need a new water ethic in this country. And if we are to prosper in a rapidly changing global hydroclimatic condition, we need that new ethic now. And perhaps the basis of that new ethic should be founded on the water ethics of those who were here before most others arrived. We know what to do. It's time to do it. Thank you.